We have one little thing to do more. Question? The question is about the result. That's we are talking about the differences of the median of the differences here. Yes, this is the confidence interval for the median of the difference. So this means that for the medians we couldn't claim an effect here because the zero, yeah. Good. Last example, also a bit of silly example, also related to my childhood, but let's not get carried away about that. I did mention my mom already. Let's not mention her again too much. My father is a very good guy, still around. And maybe he's even listening in. I think he sometimes checks in. Hi, Dad. Hope you're okay over there. See you soon. Anyway, this is about bottle or no bottle as infants, and about dental health. So we have two group data here put in a bit funny way. We have some kids who had the bottle and some did not have the bottle. And then we record the age of your first tooth problems, to put it a bit loose here. So we are wanting to compare the mean age between two groups of kids here. So it's a two sample situation. The data could have been put in more nicely in two samples, two groups, but here are two samples sort of in between each other. There are the no babies and there are the yes babies, and we have some age. And if you have a high age of your first problem, that's good, right? Low age is your first problem, it's not so good. So we want to compare those, and again, as an example of data that doesn't really appear normal, right? Normal distribution would not be the first idea here. So to have some example of where we could use the last method, namely the two-feature comparison nonparametric bootstrap, or doing the nonparametric bootstrap comparison of two features, two sample comparison. For instance, we read in the data from the two groups, so these are the ages from the no group and the yes group in two separate vectors like that. I set the K, I do the simulation, I do the computation, 1, 2, 3, 1, 2, 3, and I look at the numbers. Same thing again, right? Here again, I just do the non-parametric or the resampling of my own data. I do it for the X data and I do it for the Y data. I do it separately. Then I compute, this is a copy again, I compute the difference of all the means, and I look at the quantile and I get this result. Again, confidence interval for the mean of the two groups. And here is the general method box, the last box of today, where I formulate the same thing. I simulate using my own data, resampling each group. I compute all the feature differences and I look at the distributions. Right now we've done this for the 4th time in a row with a slightly different aspect. That was two sample bootstrapping. Here's another example. What if we wanted the 99% confidence interval for the difference of medians? Well, it's very easy. Maybe let me stress that. The 99% makes us change the quantile call to have the right percentages here that corresponds to the wanted percentage here. And the feature definition is coming in here in where I actually compute the features, right? It's pretty straightforward, I find. And then we get the results. So, to sum up on what I just did with the bootstrapping, I gave you 4 boxes. I gave you 2 boxes for parametric, 2 boxes for non-parametric. I gave you 2 for 1 sample, 2 for 2 sample, right? 1 and 2 sample non-parametric, 1 and 2 sample parametric to repeat myself. And by features, it could also just be those means that maybe we're most used to think about, but it could be any feature. And we could maybe, just maybe also, we did that once, maybe do some hypothesis testing, because the confidence intervals include those values that we accept. So by that we can do confidence intervals to a certain extent. So that's it for the doing statistics by simulation. Let's get the winner by the last question. Most of you chose the safe one, blue, but I was happy I brought this question because I don't think, or maybe I wanted to stress at the end, yes, in our course, we are just gonna check that you know what bootstrapping means for 1 and 2 samples. That's where I gave you 4 explicit method boxes that you are expected to know about. So if you see results from R, from things like that, you should know what that means. However, it's a very important point that this principle could be taken on to any kind of statistics. We're not going to do it with you, but you can do it in regression. You can do it whatever you meet in the future, the same kind of simulation stuff. It's a very generic idea. Who did the winning game today? Baguette. Why don't we try another thing today? Would boy here, number 3, would he or she like to be applauded by, whoa, good job there. And what about the hi who lost the first place? Would he or she, good job. And then to the winner, let me introduce you, ladies and gentlemen, the highest performer of today, Mr. Baguette. Thank you. Well, thank you for spending the day with me, and enjoy, and see you next week.